Hi everyone. We're going to study chapter 10. Okay, I haven't added the audio file yet. Okay, but I'll have for chapter 8. See, under the regular lecture, I have audio part 1, part 2 for chapter 8, and the same for chapter 9. Uh, if you feel okay, you can understand everything. You don't have to listen the audio. So now for chapter 10, we're going to study chemistry. The first thing, if you go module open that, this regular one, so you should make a copy of periodic table. Okay, go down to right here, make it bigger. Uh, so you have to make a copy. So when you take next test, which will cover chapter 8, 9, and 10, um, at least 30%, maybe a little more, of the questions, the multiple choice, you need to use a periodic table. So I'm going to ask you a lot of questions. So make sure make a copy of this first. Okay, so now we start chapter 10, uh, periodic law. So we start chemistry, and chapter 10 mostly we're going to discuss the periodic table of the elements, and we're going to study the chemical property of different elements. First section we discuss what is chemical change. So now before we discuss chemical, we want to study what is physical change. Physical change does not change the molecules. Means before, after, the molecules the same molecules. Like ice. Uh, okay, when temperature increase, change to water. Now, then water when temperature increase, change to steam. So change from solid to liquid, then gases. But before, after the change, the molecule still same. Uh, so two hydrogen when oxygen combine, that's water molecules. It doesn't give you new molecule. Okay, so another example, iron, that's metal. When temperature reach 1600 degree Celsius, it change to liquid, solid change to liquid. Okay, so now if you check before after the change, it's the same molecule. But chemical change will always form new molecules. Chemical change, new molecules. Okay, so here are some example, like when the iron again combine with oxygen. Okay, so that's resting. So now see what happens before you have two molecules separate. After they combine, this is the new molecules. Two iron combine with three the oxygen atoms. And the property of these new molecules totally different. Totally different. It's soft, and it's brittle, right? Another example, see what happens if we have zinc and sulfur combine the two elements. This is metal, non-metal. After combine, give you zinc sulfide. These new molecules. So the physical and chemical property is going to be totally different. Different from zinc, different from sulfur. And here is from our textbook, give us the example. See the property of the zinc, property of the sulfur, and the property of the new molecules. You will see everything change. Become brittle. The temperature melting point change. Okay, and the density change, even density, density for zinc is 7.1, and sulfur is 2, and this one, the new molecule becomes 3.5, and also other property. So you're going to have a new molecule after a chemical change. Now we need to remember we have three classes in chemistry. So when we study physics, we say we have three states: solid, liquid, and gases. When we study chemistry, we say we have three classes. Okay, now the first one we call elements. That's the elements in periodic table, which is most simple substances that cannot be broken down chemically. Okay, so the elements and atoms are the basic building block. So in chemistry, we just use different atoms, make molecules, or break down molecules, give you the elements. That's the basic building block. In the whole universe, 75% of matter is the hydrogen, and another 24% the helium. So see the first two elements in the periodic table occupy 99% of the universe. Everything else is only 1%. Okay, so this is very important to remember. 70% of hydrogen and 24% of helium. So now in the Earth, we have mostly 4 or 5 elements: iron, oxygen, silicon, and magnesium. And these four make the 96% of Earth. Okay, so now it's the first time we want to look at the periodic table. I open this file here. See, periodic table. Okay, number 1, number 2, number 3, 4, then 5 to the 10. Okay, then so on. We're going to discuss more detail. Now the first two, number 1, hydrogen, number 2 together make 99% of the universe. Okay, let's go down this one, then continue to discuss the second one. Now, second class we call compounds. So compounds consist of 2 or more elements with their own properties. Like the example we just mentioned, zinc sulfide and carbon dioxide, we call them compounds. So when elements combine chemically, we call compounds. Now, the third class we call mixture. This one is when the elements or compound combine physically. They just mix together, like seawater, air, concrete. So remember a few examples. They are mixture. They are not the compounds. So like seawater, you have minerals, water of course first, minerals, and the salts are mixed together. The ocean of the Atlantic or Indian Ocean, the water can be a little different. But compound, no matter where, the compound will always same. Okay, so the mixture is when the elements compound mix physically, and compound when elements mix are combined chemically. So they are different. Okay, so if I have time, you can read this some details. And one important property between the different the compound mixture is the when compound combined, always the fixed percentage, fixed ratio, 100 gram of the oxygen always combined with 88 uh, gram of nitrogen. Okay, so now what if I have a mole? That 100 gram oxygen, 100 gram of nitrogen will still make the same amount. Uh, and 12 gram of nitrogen going to stay away because you cannot change the ratio. Okay, so now section 3, we discuss atomic theory. Well, we talk about atomic theory of the chemistry. So matter consists of molecules, and molecules consist of one or more atoms. The molecules consist of one or more atoms. Some molecules, for example, like the helium, helium like stay alone, we call the inert group, right? The noble gases. So like other like neon, they like stay alone. So one atom equals one molecule. So now the chemical formulas He, because only one. So now sometimes you see same atoms, same but more than one, right? Like oxygen, most time you see two combined. So the formulas O2 tell you two atoms of oxygen combined make one molecule. Well, sometimes you can have different number like ozones. You always have three combined, so be O3. So now you see many different atoms combined make molecules. Well, now we're going to call different name like water. We don't call hydrogen or oxygen. Okay, because we have more than one, so we call a different name. Ammonia, that's one nitrogen combined with three hydrogen. So now the molecules, of course, can be very, very complicated. Can be a few hundred, even more, combined together. Okay, but as the physical science class, we're not going to discuss detail. Just remember a few simple example. Different molecules. Some the single atom. Okay, more atom of different atoms. Okay. So a molecule is formed when two or more atoms join together chemically. Chemically. Okay. So now, what's the difference between molecule and a compound? The compound is molecules that consist of at least two different the elements. Okay. So it's different elements combined. So I will say all the compounds are molecules, not all the molecules are compounds. Okay, another type compound we call ionic compounds. This one we usually don't call molecules like the ions. Okay, sodium, chlorine, one lose electron, one catch electron. So they are not the atoms anymore. They are ions, the charged atom. They combine give you ionic compound. We're going to discuss that later. Okay, so now section 4, we're going to study metal and non-metal. Okay, let's see the big version of a periodic table. I hope everyone make a copy and you're going to use it. Well, if you have a test in classroom, of course, I will give you one. Now, metal, non-metal. You see this line here, this line, thick line, separate all the way like this. Okay, we can ignore the last part first. So now everything on the left side of this line we call metals. They're metals. Okay, now everything on the right side, okay, lose this line. Everything right side uh, we call non-metals. Okay, plus hydrogen. Hydrogen really belong to this part. So hydrogen is non-metal. Okay, so this line separate metal and non-metal. Left side, except hydrogen, we call metals. Okay, let's go back to our lecture. So now we assume, okay, this number, the total number still increase because scientists still make new elements. So it's about 110. So you're going to find 88 metals and 22 non-metals. And include, of course, hydrogen, non-metals. So now, what's different? Why we call them metal, non-metals? Okay, so first, the metal are solids mostly. Okay, so if you see the table, we'll go there later. You see they all are all the black color. Okay, except mercury. Mercury. Now the non-metals, they have different solid, liquid, and gases. Look this. Most of them are black color. They are solid. And one exception is the number 80, mercury, liquid. So black means solid, well, at room temperature. At room temperature. Okay, about 70 Fahrenheit. Okay, so now the non-metals, you see right side of this line. Okay, so you have solid, all the gases, include hydrogen, and also have liquid. So non-metal you have all different kind, and the solid, the metals, mostly the solid. Okay, now the second is very important. At least this one, I may ask you. The metals are good conductor. Good conductor for electricity and for the heat, transfer energy. And the non-metals, they are insulators. But the carbon is an exception. And also the metal shining, has luster, and non-metals are not. Okay, and physically, the metals are more flexible. You can make a different shape. You can make the tools like make a knife, a screwdriver, very useful. But the non-metals are usually they are more brittle. But remember, in chemistry, there are always some exceptions. Like hydrogen is the non-metal. But behavior, we're like the active metal. We can discuss later. The carbon, we already mentioned, is a non-metal. Okay, and but it's very good conductor, similar to metal. Now, next section we're going to study chemical activity. This is very important. The whole chapter of chapter 10, we're going to discuss the chemical activity. So what is chemical activity? Some metal and non-metals, they readily combine. They like to combine to others, make compounds. So we see they are very active. They like combine each other. So chemically active. But some elements we mentioned like argon and helium, uh, they have a little tendency to combine with others. Well, they like stay alone. So we say they are uh, inactive. Uh, so the active one like join chemical reaction. Uh, the inactive one uh, do not like join chemical reaction. Okay, so now give you two examples. The sodium, the example very active, and the gold example of inactive. So that's activity. So now, so if you take a sodium out of container, usually you have to keep in noble gases. You take out in the air, what happens? The color going to change in few seconds. Why? Because it's active. But the gold, we use gold to make a ring. When you married, you wear a ring. Why? Because inactive. So the color will keep a lifetime. Means love never change, right? Okay, so this is example of inactive. Uh, and also, when combined with other elements like chlorine, sodium going to have very strong reaction, very strong chemical reaction, a lot of energy involved. And when gold combined with chlorine, very weak, not much energy. So now after make compound, well, because it's so strong, we're active one. Okay, so we need a higher temperature to separate the compound. And the gold, the compound not very strong. So you just need 300 degrees to separate. Okay, so usually for the compound, active elements make a very stable compound. And the inactive elements make unstable compound. Okay, so now more example, like when you find the mine, gold mine, and they usually free metals, pure gold, because very inactive. But if you find a lead, which is very active, well, you have to do something because the lead combined with others like a sulfide, and you have to separate between. Okay, before you can have the lead. See, I give you example. Very inactive one, like stay alone, and the active one will combine with others. Now, section 6, we're going to study some very important elements. So we're going to study three families. Well, in periodic table, there are the vertical columns. Okay, so now the three group or three family we're going to study. And by the way, the elements in same group, they have very similar chemical properties. They are similar, not the same. So the three we call the alkali group. That is first column in periodic table. So totally there are 6 elements. They are all metals, and they are very, very active. Well, for the metals, they are most active. Now, the second from the last one, second next to the last column, we call halogens. Okay, there are totally 5 elements, and they are all non-metals, and they are very active. They are most active non-metal. Now the last one we call noble gases, or we call inert group. Okay, so totally there are 6 elements. They are all gases, and they are very, very inactive. So these three groups I want to pay attention. The vertical. Okay, the first one, most active metals. The second from last one, very active non-metal. And very last one, very inactive. Very inactive. They are also non-metals. Okay, so now look again. Uh, this is not this hydrogen. But hydrogen are similar. But this is not alkalis. So 1, 2, 3, 4, 5, 6. That's the lithium, the sodium, potassium, rubidium, cesium, francium. Okay, so you don't have to remember the name, but you should know the first column. They're most active metals. So now the second from last one. What do we call them? Halogens. Fluorine, chlorine, bromine, iodine. Okay, 1, 2, 3, 4, 5. We still don't discuss that one. There are most non-metals, most active non-metals. Very active. So active means what? They like combine with others. Okay, so the last one, well, the helium, neon, argon, krypton, xenon, radon. They're all gases. They're noble gases. What we call inert group. They are most inactive elements. So one question I may ask you, okay, pay attention here, So I may give you several elements, So how about let's say, that's the first period, second period, from number 3 to number 10. So if I give you a name of few elements, I may ask you which one is the most active metal. You're going to choose the first one, right? Because alkalis are the most active metals. If I ask you which one is most active non-metal, you should choose that one, right? Because halogens are most active non-metals. Okay, then if I ask you which one's most inactive elements, you choose the one from the last one, right? Because noble gases, inert group are most inactive. Okay, so I can ask you all over the table. I'll give you a few elements. Ask you which one's most active. Metal should be the first one. If I ask you most active non-metals should be second from last one. Okay, and if most inactive should be the last one. By the way, so this is called the periodic table, and by order of the atomic number, number 1, number 2, number 3, 4, up to 10, then 11 up to 18. Okay, so if I ask you elements, likely I will give you the number. So you just check by the order. 19 to 36. Okay, so on. Okay, so now the middle part, see, this part we call transition elements. They're more complicated. Not likely I will ask you anything. Not at least the property. I may ask you elements, let's say 77, then I'll ask you fun information like a boiling point, melting point. Okay, we can discuss that later. And here's the example. If you don't know how to answer, you go this corner. This give you example. Okay, now, and we have some elements outside the table here. See, that's 57. The next one's 72. So where's the 58 to 71? Right here. And we call real Earth. Real Earth. Okay, Then also uh, 89. Next one 103. 104. I'm sorry. Where's 92 103? It's right here. Okay. So if I ask you elements, I'll give a number. Let's say 67. You'll find, oops, it's not there. Well, it's here. Did I say 67? Then I will ask you, okay, atomic weight, the density, the boiling point, melting point. We can discuss this later. So anyway, so that's the some basic information about our periodic table. Okay, so the three. Okay, you should pay attention. And you should know which one's active metal, active non-metal, the most active metal and non-metal, and most inactive elements. And we will discuss why they are active or inactive later. Okay, so now the periodic table. Okay, let's see. Periodic table was first given by Mendeleev, the Russian scientist. So we still remember his name. Mendeleev gave the first periodic table. Well, that time is about 1869, 150 years ago. 170 years ago. Okay, so that time people only knew 63 elements. So I just make a copy here from the internet. You see the table is much smaller. Okay, Mendeleev first get the idea, make this table. Okay, so now because that time people want study the chemistry, they want to know the property. So many elements, how we can find the rule. Okay, for example, when you make a compound, you want to know which one and which one can make a better compound. So Mendeleev got the first idea. So he arranged the elements this way. Start from metal to non-metal. From very active metal, then change to until the last one give you very inactive non-metal. Then a new period again from very active metal, very inactive non-metal. And by the atomic number, 1, 2, 3, 4. That time people didn't even know the helium. Okay, so then Mendeleev tell us, well, we have some empty space here. We don't have such elements yet, but someday someone gonna find that. Later, other scientists find the new elements. They just fit in. The property Mendeleev already tell us long time ago. Okay, here's how the periodic table looks like today. Remember, make a copy, right? Okay, so what kind of information we can find? Okay, look here. If we use this table, this give you example. I'll give you example. This for zinc, number 30. Number 30 is right here, zinc. Of course, I will ask you different elements, can be any one in periodic table. Now, how you can find information? Okay, so first, the name. First one is the name. Okay, name of symbol. ZN. So what's the name? What ZN means? At the bottom give you that. Zinc, Z-I-N-C. That's one question they ask you. And now, the atomic number. This number is very important, 30. So this number, of course, you can find the position of the zinc in periodic table. And also this tell you what? This tell you the number of protons and the number of electrons. So this atom, zinc, has 30 proton, the positive charge, and 30 electron. Okay, now the third one can tell you atomic weight, weight of one single atom, and unit is U. These only things not given. You need to remember. So where you can find the weight, right here, 65.39 U. The unit is U. And remember that's atomic mass unit. 65.39 U. Okay. So now, of course, this color tell you zinc is what? Is solid. It's solid, right? It's solid. And now what else? Boiling point and the melting point. Okay, so see under this atomic number, you can find a boiling point and the melting point. 1180 what unit? Kelvin, K. And the melting point is 692.73. When under the blue number here, give you density, 7.13. What the unit? Gram per centimeter cube. Okay, so they give you this as a K, that's K, and the gram per centimeter cube. Okay, so you can find all information from this example except the unit of the atomic weight. Okay, then the state, solid, liquid, gases, that's by color. So if color is blue, like mercury, the blue color, so that's be liquid. And if the hydrogen or helium, the color be red, okay, tell you that is the gases, right? Okay, so we're gonna stop here today. Thank you.